Hello students, I welcome you all in this video. In this video, we're going to talk about a question. This question is three particles A, B and C are situated on the vertices of an equilateral triangle ABC of side D at time t equal to 0. Each of the particles moves with a constant speed v. A always has its velocity along AB, B along BC and C along CA. And then we need to find out that at what time will the particles meet each other, right? So the diagram that we have here, we can see A is always pointed towards B, B is always pointed towards C, and C is always pointed towards C. When I'm saying pointed towards this and pointed toward that, means at that particular moment, the direction of velocity of A is towards B, and the direction of velocity of B is towards C, and C is towards A, right? So they are moving on this curved path, and then they are meeting at the center of the triangle. And we need to find out that how much time they are taking to meet, right? So for this question, I will use a very simple concept. The concept is this: time is distance by speed when acceleration is not there. And we can say that this is displacement by velocity. But the condition here is that direction of displacement and velocity has to be same, right? So if I draw the triangle, let me draw the triangle. Consider this is the triangle ABC, right? So here what is happening? This is the point O where the particles are meeting. And if you talk about the direction of velocity, let us consider the particle B. So direction of velocity of particle B is this. Particle is moving with the velocity V, right? But if you talk about the component of velocity towards displacement, what's the displacement? Displacement is just BO distance. So let us draw a line. Let us draw the displacement line. Now this yellow line is the displacement line. Okay. Here the particle is moving this way. This angle is 30 degree because that yellow line is the angle bisector. So that angle is total angle was 60 degree. So this angle is 30 degree. Now, if you talk about velocity, that means velocity we got is V cos of 30 degree. That means V into root 3 by 2. That means root 3 V by 2. Okay. Now let's talk about the displacement. If you consider this BC line, this BC line is having a distance D. And if we draw a perpendicular line from here, consider this M. So OM is basically going to bisect this BC line. So the total distance was D. Now this distance B to M is just D by 2. And we have to find out this one, X suppose. So X cos of 30 degree is going to be D by 2. From there we can easily find out the X value. So we can say X cos of 30 degree is D by 2. That means X is equal to D by 2 times cos 30. Cos 30 means root 3 by 2. 2 cancelled out. And the displacement, which is X that we got, is D by root 3. So now if you talk about the time is going to be displacement by velocity, and the directions are same now. So we can easily take the ratio. That is root 3. That is going to be D by root 3. That is displacement. And velocity is root 3 V by 2. So we know that that 2 will shift up. So the time is going to be 2D by root 3 into root 3 is just 3. So it is 3V. So this much time the particles are taking to meet each other, right? I hope this is clear to you. Thank you.